Welcome. In this demonstration, I'm going to show you how to work with binomial distributions. Now, what I have in front of you is a spreadsheet with ice cream sales broken down into nothing, 1 scoop, 2 scoops, 3 scoops, and any purchase. So we're looking at probabilities, and what I'm going to insert here is a percentage in all of these. So let me change all of these to the percentage format. And let's say that the probability of a customer buying 1 scoop is 55%. Let's say 25% for 2 scoops and 5% for 3 scoops. So now we can calculate the rest. So any purchase would be equal to the sum of those. And purchasing nothing would be equal to 1 minus that sum. So we have the probability that a customer will come in and not purchase anything or purchase nothing, 15%, and then broken down for each of these others. Now, we're going to work with this binomial distribution, but first of all, we have to talk about the Bernoulli process and ask whether this fits within that model. So a Bernoulli process is something that has one of two possibilities. So think of flipping a coin. It's either heads or it's tails. And that it has an equal possibility every time you do it. So in essence, it's a fair coin, right? So every time you flip it, there's a 50-50 chance that you'll get heads or tails. Well, 100% chance that you'll get heads or tails, 50% chance that you'll get heads, 50% chance that you'll get tails. So we have to stay within that parameter to do our binomial distribution calculations for probability. So we're going to have to set this up with these kinds of questions, right? So kind of a yes-no. If you think binary, yes-no, and the outcome for that will fit, then it is a Bernoulli process. Okay, so let's move forward with this. Now, anytime we're working with a spreadsheet like this, we are building a mathematical model. And I want to introduce a few things, best practices for building mathematical models. And one of those is that when you come back to the model later on, giving yourself some clues, some hints, if you will, how to use it. So you build this model, it's calculating something for your company or for yourself personally. You set it aside for a couple of days, a couple of weeks, a couple of months, and then you come back to it. How much do you remember about what you had done? So here's an example. We're not entering the percentage for nothing. We're calculating that. We're not entering the percentage for anything or any purchase. We're calculating that. The only ones we're entering are these. Now, how would I remember this 2 months later when I come back to use this? I may or may not. Depends on, how often I used it and that type of thing. One way to do this is to color code these. I tend to pick a rather obnoxious color for this so that when I go into a worksheet like this, that I can see immediately, oh, these are the ones I need to adjust, so that if I change this, then everything else changes, right? Well, at least the ones that are not in yellow. Okay, so we're going to stick with that, that best practice. So now what we want to do is ask some questions that we need in order to provide an answer. So let's just talk about providing an answer here. So we're going to get an answer, but we're going to get an answer to what? Well, it's going to be in the form of using the binomial distribution. So binomial distribution, we're going to use that function, and it has a number of parameters, the number of trials, the probability, and cumulative or not. So we're not going to fill that out just yet. We want to know how to populate those. Now I could just insert numbers into that and certainly get an answer, but what I'm trying to demonstrate here is producing a mathematical model in the form of a worksheet that you can do some what-if analysis with. So first of all, and I'm going to copy these over rather than typing them in, simply because it saves us time. And So I'm asking, or I'm making a statement. There are A, and I'm using A as a variable here. So there are a number of customers in the store, and so we could say A equals, and let's just write justify that. And let's say there are 3 customers in the store. Now, I know that's something I'm going to be adjusting, so I'll put it in yellow. So that's the first question that I have. How many people are in the store? Because ultimately, I'm attempting to answer this question right here. What is the probability that, again, a variable, B, number of customers currently in the store will purchase something, C, all right? So we need a variable called B, and we need a variable called C, and we'll write justify those. And again, these are things that I'm going to be changing. So how many, what's the probability that, let's say, 1 customer out of the possible 3? So I have to know how many customers are in the store. I also have to know this criteria of, well, how many am I asking the question about? I'm asking it about 1 particular customer. And we can change this after we build this model, but this is a starting point. Now, this next one, this C, will purchase. Well, here are all my purchases. So how do I manage that? Good question. The best way is to go up to your Data tab and go over here to this little icon right here that gives us data validation options. And what this will allow us to do is to create a drop-down list based on that information. So I'm going to select that. I'm going to select the list. And for my list, I'm simply going to select the cells that I want included in that and click OK. So now I have a drop-down list that includes those. And if I were to change these, then this list would change. Now, I'm not going to put them in yellow because presumably I am doing work for this ice cream store. Maybe I work there, own it. Or just an employee, or maybe I'm volunteering my time to build my data analytics, business analytics skills, but it's for the ice cream store. So I'm not going to typically change that. All right, but with this, I can decide, is it nothing, 2 scoops? What question am I asking? I'm building the formula for my question. So my question is, given that there are 3 people in the store, what's the probability that 1 person is going to buy 2 scoops? Now, I have to do something, right? I can't just use this text string. And so I'm going to introduce what's called a switch statement. And this switch statement is going to give me my probability for these purchases over here. So nothing would be 15%, 1 scoop would be 55. So I need all of this. And the best way to do that is with a switch statement. So equals switch. And the expression is what I'm evaluating. So I'm evaluating E7. And then there are pairs. If E7 equals A4, then I want B4. If it equals A5, then I want B5. If it equals A6, then I want B6. And if it equals A7, then I want A7, or I'm sorry, B7. And if it equals A8, I want B8. And I can enter a default value. So I'm just going to enter, you don't have to have a default value, but I'm going to enter 0 as my default value. So we can see that, and we'll just change this to percentage as well. We can see that the probability of a customer purchasing 2 scoops is 25%. Now that doesn't take into account that we have 3 customers in, and I want to know if 1 person is going to purchase 2 scoops. And if I change this, then that changes to match the percentage. So now I've got some selection criteria there. Notice this is calculated, so it's not highlighted in yellow here. So when I come back, I know, okay, I can change these things. Now, just to illustrate the default, if I delete that, it shows me 0%. So let's go back to our 2 scoops. So now there's one more criteria I need for this binomial distribution. And that criteria, I'm gonna paste in the description of it, and then I'm going to talk about what this means. So this is exactly, so the probability of my question occurring, the events occurring as I'm describing them, is equal to this, right? So one will, exactly one, right? Or no more than. So the probability of this event occurring with one person, it would be less than or equal to one. Now that doesn't make a lot of sense, but if I had two, right, then that would make more sense. It could be one, it could be two, but no more than two. What's the probability of that? So we have worked with, through previous video demonstrations, we've worked with dummy variables. So I'm representing this exactly with a 0, and I'm representing this no more than with a 1. So again, I'm going to have a field here that I can modify, and again, I'm going to use a drop-down list. And using a drop-down list, I could just enter a 0 or a 1, but using a drop-down list, again, allows me to put some text in there that's more readable. Perhaps I'm passing this along to the business owner for the ice cream store, and they want to know how to use it. So again, good practices. So this time it's going to be a list, but this time I'm going to create that list. So I'm going to say exactly in quotation marks and then a comma, no more than. And now I have a drop-down list that says exactly or no more than. Now notice it put the quotation marks in there, so I'm just going to go back and change it. I don't need quotation marks. It knows how to work with those text strings in that list. So I'm going to go back up to my icon here with data validation, and I've selected that cell, so it knows that I'm working with that list in that cell. And I'm just going to get rid of my quotation marks here. Now notice that when I use the arrow keys to try to go over that, Excel thinks I want to insert something, so it's a bit of a pain to edit these. I have to actually click where I want to edit and then select that. And there you go. I have my change, no more than or exactly. Now I'm going to expand this so that no more than is visible in there. Well, now I need another switch statement because what I really need is that dummy variable. So no more than is 1 and exactly is 0. So I can do another switch statement. Oops, I keep hitting my caps lock there. And my expression is in E9. And the value here, I do need quotation marks. If the value is exactly, then I want a 0. If the value is no more than, I want a 1. And let's say my default, I will default to 0 again. Okay. So there you go. I have a 1 if it's no more than. I have an exactly if it's 0. And if I simply delete that, it's also a 0. So the way I've set this up, the question is, given these percentages, what's the probability that of 3 customers in the store right now, that one of them, exactly one of them, is going to buy 2 scoops? Now I have to build my binomial distribution function and put everything into that. So I'm going to equal binomial distribution. And my number is the idea of how many people in this case, right? So my question is really around, will one person purchase? So E6. And then the trials is represented by, well, how many people are in the store? So if there are 10 people in the store and I'm asking about one person, the probability is different than if there are only 3 people in the store. So E4. And then the probability is what to force this into a Bernoulli process, I'm asking a very narrow question. I'm saying, are they going to purchase nothing? Are they going to purchase 2 scoops, 1 scoop, 3 scoop, or any purchase? So I've created these items in column A so that I can force this into a yes/no type question. And so that percentage is represented in F7. And then this is either true or false, meaning that it is either exactly or it is no more than. And so I'm going to have that point at F9. And so what we're looking at here is, let's change this to a percentage. What we're saying that the probability given 3 people in the store that one person, exactly one person, will purchase a 2 scoop item is 42%. Now, if I change this to no more than one person, notice that it changes the percentage, 84%. That's because with the exact, it means that of the 3 people, only one of them is purchasing. But when I change it to no more than, it's saying, well, of the 3 people, no more than one person. So one person can, but doesn't have to purchase 2 scoops. So we actually have a higher percentage. Now, what if there were 10 people? This is the idea of the mathematical model that we build with a worksheet. We can start playing around with this. Now, before I do that, let me color code this. This is my answer. I like to put my answers in green. So there you go. When I come to a worksheet that I've built in the past, I can come here and know immediately, oh, I'm changing these things and I'm looking in this. In fact, let's just make it a little darker to attract my attention there. So what if there are 10 people in the store? Well, then the probability that no more than one person is going to buy 2 scoops is only 24%, right? Meaning it's likely other people are going to buy, right? So now I can change this. What's the possibility that we'll go with any purchase and we'll say 5 here. Only a 1% chance that no more than 5 people will make any purchase. So let's change this to exactly 5 people. And wow, we have still a 1% chance. That's interesting. So let's say no purchases, nothing. We have a 1% chance. And you might think, well, it's not working, but it is working. Let's say 1 scoop, 23%. It just happened that we picked a lot of things that were not very likely. So 50% of our people not buying anything, when we know that our average is 85% of the people who come in buy from us, right? Our long-term average, which is what we're basing all of these calculations on. Now, build this, play around with it. It can help you understand both the binomial distribution, but also what qualifies for a Bernoulli process or not. And one of the things you can do, and I've done this, and I'm just going to copy it in rather than doing all of this, is you can actually build a chart that will help you begin to see what this looks like. Now, this chart is based on 3 people, right? So what are the odds that 5 people purchase if there's only 3? Well, that's a problem in the formula, right? So if we change this to 1 scoop, exactly 1 person, right? 1 scoop right here is 33%. Now, the way I got those down there is I copied this, and then if I just copy it here, I'm copying a formula, and I don't want to copy a formula. So again, I can right-click and select this second value or second item on the copy list, paste list, and just paste the percentage in there. So I'll do it up here just to illustrate that it does actually work, right? Okay, so there you go. Now it's your turn to practice doing the binomial distribution.